Hello everyone, welcome to Physmatica. Let's take a look at the problems. In this series, I'm going to take a look at a lot of different problems in polynomials especially. Some of them are going to be more difficult than the others. I'm going to take a look at the different techniques. I'm actually learning a lot myself. It's very interesting, some of the problems. Most of them are medium, but there are some that are here and there much more complicated. Let's take a look at the first problem. These are more of a warm-up, I would consider them, but they're still challenging. Before take a look at any solutions, definitely give yourself 5-10 minutes on each problem, see if you can solve it yourself. And remember, in these exams that I'm taking a look at, it's not more about the solutions actually, it's more about the way that you go to your solution. So for example, for the first problem, let's just take a look at it. It is asking that if 9,876 to the power of 2 equals this, what is 9,877 to the power of 2? So one way would be just you multiply 9,877 and you have the solution, but that's not what they want. They want you to actually use algebraic way to solve this problem. So how we can do that? For the first problem is actually very simple. You just have to know this identity, which you definitely know, equals a minus b multiplied by a plus b. So that's the whole idea. And the reason why we use this identity is because we have two terms, 9,876 to the power of 2 and 9,877 to the power of 2. So we have these two terms, and all we have to do is to just find a here or b here, whatever you're going to change the numbers and substitute. So I'm going to write it like this, write the whole problem right now. I'm going to say that 9,877 minus 9,876 multiplied by 9,877 plus 9,876 equals 9,877 to the power of 2 minus 9,876 to the power of 2. Okay, so that's how I'm gonna write it. I just use this identity to write this problem. So as you can see, this is 1. So what I have right now is quite simpler. I have that 9,877 to the power of 2 equals, remember, we have this as well from the problem itself. It is given here, equals 1 multiplied by this. So what is this result here? Let me just calculate it on calculator for a second quickly. That is 19,753 plus, because as you can see, this one is going to be coming out to the other side, so it's going to change its sign, and we have the result for it as well, plus 97, 53, 53, 76. Okay, so as you can see, this is the problem that we want. What is 9,877 to the power of 2? It's going to be this, and this is equals to, let me just calculate it quickly, 97,555,129, and that is the solution. As you can see, this is what they expect. You need to write the identity or whatever, but because like in real life you would just use a calculator to solve it, but this is the algebraic method, much more interesting. Now let's take a look at the second problem. This one is a bit more challenging. Take a look at it yourself first. I'm going to start by this. I'm going to make this logic to myself that the only way I can simplify this is to find the denominator in the numerator, okay? That's the only way. There is no other way to simplify this. Maybe if there is some unique identity in the numerator, then maybe I could work it. So let's just start by expanding, because right now by looking at this we have no way of like what are we even going to do with it. So I'm just going to expand it by multiplying this in this parentheses and ry in the second parentheses. So if I multiply bx in the first parentheses, I'm going to get r2. Oh, let me just actually write this with another color so it's more clear. This is the second problem. I'm going to get r2b x3 plus 2 r2 y2 bx plus b3 actually x y2, yeah, because that b got multiplied, plus now ry, it's going to be r3y x2 plus 2b2 x2 ry plus ry3 b2. Okay, so this is what we have now. 1 2 1 2 3 1 2 3. Okay, 6 terms as well. I didn't miss anything. Always like check your sanity first. Bx plus ry. And what I'm saying here is that I want to somehow find this in here so I can just simplify everything, cancel them out. But how we can do that? On the exam itself, you might actually find this a bit challenging, so you have to solve a lot of problems like this so you're a bit faster, but you probably have to do it because you might need to find the terms that match with each other. Okay, so this is exactly like that. So I did this problem, I solved this problem before, so I know exactly, but it took me like 5 minutes. So the idea is that this first term, this term here, and this term here, you can use these. I'm going to write them, group them together to find the bx term. Okay, so I'm going to get this. I'm going to get a2 bx3 plus 2b2 x2 ry plus b3 x y2 y2, okay, this term, plus now I'm going to get this term, and this term. So I'm going to get r3 yx2 plus 2r2 y2 xb bx plus ry3 b2. Okay, so now what is my purpose here is that I'm going to factor bx from here and I'm going to factor ry from here. Let's just write that and see what we get. If I factor out bx from here, I'm going to get r2 x2 plus from here, what do I have? I have 2, 1b gone, 1x gone, ry plus from here I'm going to get b2 y2. Okay, then here I'm going to get, if I factor out ry, and again remember we are factoring this because this is in the denominator, so we want to just cancel them out. If I factor out ry here, I'm going to get r2 x2 plus from here I'm going to get 2 ry xb plus, and from here I'm factoring ry, so I'm going to get y2 b2. Okay, over bx plus ry. Now we have this. So take a look at this, what we have right now. What is unique here? If you take a look, we actually have these two terms exactly like each other. These two terms are the same. So now I'm going to factor that one out as well. So what I'm going to get is this, r2 x2 plus 2b r xy, that is x xy plus b2 y2 multiplied by bx plus ry. Okay, so what I did, it's again like you have two terms and I just factored out the mutual term between them. Okay, it's a common term between them, so that's it. Then I have a bx plus ry here, and that is exactly what we did. We just canceled this out, and now we have r2 x2 plus 2 rb xy plus b2 y2. And take a look at this. What is this? This is another identity. So what is this identity? You can simply see that this is actually rx plus by to the power of 2. Okay, so that's the solution, because like if you solve this, you're going to see that this is going to be r2x2 plus b2y2 plus 2 rx by, which is exactly what we have here. So this is the solution, rx plus by to the power of 2. So as you can see, it is a simple problem really, but you still have to be good in algebra to solve it. You need to know to find how to multiply and how to do the grouping and how to do the factorization. So this is the whole concept here. Now let's take a look at the last problem. This problem is the one that I added as a short video, and I going to solve it right now. So the problem is find all z such that this term makes sense. So, okay, this is from a USA International Mass Olympiad training, so it's not actually difficult. Let's just write it. We have a square root of 5z plus 5 minus the square root of 3 minus 3z equals 2 square root of z. So what I did, this is 2. This is 2. And what I did is just like, I just simply put this on the other side of the equation. And the reason is that, as you can see, every term here is a positive term. So we can, because there are square roots, and we know the domains for all of them. So let's just take everything to the power of 2. If I take everything to the power of 2, I'm going to get 5z plus 5 minus 2 multiplied by 5z plus 5 multiplied by 3 minus 3z plus 3 minus 3z equals 4z. Okay, so because this is going to the power of 2, everything go. So this is what I did practically. This is the first one is just the identity. So I write the identity, and the right hand side is just taking everything to the power of 2. So square root's gonna go away. So now let's just solve this. I'm going to get, so if you just multiply this, you're gonna get, what I'm going to get, let me just solve it. It's going to be, so I have 5z multiplied by 3, it's going to be 15z plus minus 15z2. Then I have a 15 here, then I have a 15z there. These gonna go away with each other. So if I just solve everything, and then if we just add these together as well, this term, I'm going to get 2z plus 8 minus 2 square root of, so I have a 15 minus 15z, so it's just going to be 15 1 minus z2. All I did was just factor that out. Remember, this is 15z2 plus 15, so I just factored 15 out, equals 4z. Okay, so this is now what I have. Now, how do we continue this? Just make everything, again, simpler for yourself. You can see that everything is divisible by 2 right now. So let's just make it more simple. I'm just gonna divide everything by 2. So it's gonna be z plus 4 minus square root of 15, 1 minus z2 equals 2z. Then I'm gonna bring the z to the other side as well. So this one, what I'm gonna get a minus z. So I'm going to get that z minus 4, right, equals, yes, equals 15 minus 1 minus z2. So this is what I have. And then as I have this, I'm going to take everything again to the power of 2 to get rid of the last square root. So what I have right now is that z2 minus 8z plus 16. Again, I'm just taking the this to the power of 2, so it's an identity. As you know, this identity, we just used it, equals, and this to the power of 2 is just gonna, minus is going to go away, square root is going to go away because everything is to the power of 2. 15 minus 15 z2. Okay, so now let's just solve this, and as you can see, it's going to be, so I'm going to bring everything to the other side. It's going to be 16z2 minus 8z plus 1, because this is going to be minus, equals 0. Okay, this is now a quadratic that we have. Let's just solve this quadratic. It's very simple now. It's going to be, what is this? You could just solve it for the delta, but remember we have a 16 here, so you could just solve this by completing this square. I can just say what is this by looking at it at this point. This is going to look something like this, 4z minus 1 to the power of 2. I'm not gonna put more time to solve this. Just try to, if you want, just try to get the delta, and from there you can solve it. This is going to be divisible because you have 8 here. So what we get from here, z equals 1 over 4. Okay, so that's the solution, and 1 over 4. So that's the solution. And to actually make sure, you could just like add this to the first equation as well here to see if that's the does make sense. And you could use it, and you will see that is correct. So this is the first part of the problem, just simple factorizations and manipulation. Please let me know in the comments if you want me to do more explanation, because I feel like sometimes I'm just skipping part of the solution. So just let me know about that. I don't want a video to be very tedious. I'm sure most of you guys know this. And now let's go to the second section and take a look at the other part, which would be completing the square. Okay, so now let's take a look at the completing the square examples and problems. Again, try to solve it yourself first, then you can take a look at the solutions. Each problem has multiple ways, so you might come up with something very interesting. Especially the second problem here is actually my favorite one as well. There are multiple ways, at least like 8-7 very good, clever ways to solve it. Let's now take a look at the first one. It states that let m be a given real number. Find all complex number x such that we have this equation, and this one needs to hold. This is from a USA Mass Olympiad training. I think it was in one of their campings. So it's interesting to take a look at. And as you can see, if you know how to do completing the squares very quickly, this problem is very easy to solve. It's like a cake. So let's just start it from the start. Let's see what we can say. So for the first problem, I'm just going to say that imagine I want to do completing the squares, and for doing that we need to understand the identities. First, the simplest identity, if I have a plus b to the power of 2, this is equals a2 plus 2ab plus b2, correct? So I can also write this in a different way. I can just say that a2 plus b2 equals a plus b to the power of 2 minus 2ab. Okay, so this is now the different form I can write this. And if you take a look at the equation here, if I say x over x plus 1 equals a and x over x minus 1 equals b, that's exactly what I have. So I practically can rewrite everything in this form. So I will have a2 plus b2 equals m2 plus m, and from here I also have this. So I'm just going to substitute this side for the left hand side here that I have. So I can write a2 plus b2 as a plus b to the power of 2 minus 2ab equals m2 plus m. Okay, so now let's just write everything. Let's just put a and b here, substitute it back, and add them together, and then multiply them together here and see what we get. So I will have x over x plus 1 plus x over x minus 1 to the power of 2 minus 2 multiplied by x over x plus 1 multiplied by x over x minus 1 equals m to the power of 2 plus m. Okay, so this is what I have. Now let's just add them together and see what we get. For the first parentheses, I'm going to get x2 minus 1 over 2x2, correct? To the power of 2 minus 2 x2 over x2 minus 1 equals m2 plus m. So I just simply, this one is just a multiplication, and this one you just add them together. This is now what I have. If you just, again, pay attention here, if you multiply these two in this parentheses, you can see these are the same. So practically here what we have is that a2 plus b2 actually equals to a multiplied by b. So this holds here on the left hand side. What I can do here is that I'm going to just say do another substitution, because we just want to make everything, again, as simple as possible. In this problem, that's the whole idea. You want to make a complex looking equation to something that you already seen before. So if I say u equals 2x2 over x2 minus 1, then I can just simply write this as u2 minus u equals m2 plus m. Okay, that's all I did. So I did multiply the two, and then it's just going to be u, and I substitute back, and that's it. That's all I have. So now in here what I'm dealing with is just a simple quadratic. And as you can see, we went from a complex looking equation that we have in the problem to a very simple quadratic equation. Now, let's see how we can solve this quadratic equation. If I bring back the m2 minus m to the left hand side, write this, you can just take the delta here, but why do that? There are better ways. If you are, again, paying attention, you're looking for two roots here that when they're multiplied by each other, I have minus m2 minus m, and when they minus m2 plus m, and when they are added together, I have minus 1. So if I just take one m out of there, I'm going to get minus m multiplied by m plus 1, correct? So that's what I have. And if you see that this is actually the roots themselves, because if you multiply them, you get this, and if you add them, you get minus 1. So I can just simply say that u equals minus m and u equals m plus 1. Okay, so I have these two solutions from the quadratic there, and then I know what is u as well, as we already substituted. U is 2x2 over x2 minus 1, so let's just substitute it back for the first one. It's going to be 2x2 over x2 minus 1 equals minus m for the first root, so it's going to be 2x2 equals minus m x2 minus 1, and from here we solve for x, and x is going to be plus or minus a square root of m over m plus 2. I'm not just going to go through everything because that's just very simple now. It's going to be tedious. And for the second one, it's going to be 2x2 over x2 minus 1 equals m plus 1. And if you solve this also for the x, you're going to get plus or minus a square root of m plus 1 over m minus 1. So these two are the solutions, and as you can see, we solve this problem very simply just by practically completing this square. Let me just write this better. This is another one. Completing the squares and made everything much simpler. So that's the whole idea here. Now let's take a look at the second problems. For the second problem, I'm going to move this somehow in a more space. Let's see, maybe here. Yeah, this is better. Again, first try to solve it yourself, and now we're looking at the second problem. Second problem says that given that x2 plus y2 equals 14x plus 6y plus 6, what is the largest possible value that 3x plus 4y can have? So I'm going to put the link as well for the solutions for these problems. It's very interesting. You can come up definitely with something new if you think about it, but I'm going to solve it the way I came up with it. First, let's by just grouping everything together. So I'm gonna say x2 minus 14x plus y2 minus 6y equals 6. So I'm just grouping x's and y's. For this one and for this one, we want to use completing the square. How it's going to look, it's very, if you don't know how to do completing the squares, you can just go look at the Wikipedia, or there's a lot of tutorials you can watch. The idea is that we just add something to the both side, and then one of them, it's going to be one of the famous identities, and you're going to have a perfect square. So that's the whole idea. In here, if you consider minus 14, if you divide this by 2 and then take it to the power of 2, you're gonna get 49. So you can just simply write this one as x minus 7 to the power of 2 plus, and this one again, you have the 6 divided by 2 is going to be 3, and 3 to the power of 2 is going to be 9. So that makes a perfect square. So you can just simply write this as this equals, and now for this equality to hold, because you are adding 9 and 49 to the left hand side, so you have to naturally add it to the right hand side so it stays equal. So practically nothing changed in what you did in this equality. You just added something to the both side. That's what we have. And now if we just write it again and add everything together, we're going to get y minus 3 to the power of 2 equals 64. And this is what we are going to deal with right now. So if you pay attention, so you need to understand what is this equation. This is the equation of a circle. Okay, so as you know, this is how the equation of a circle looks like, which h and k are the centers because the center now is shifted and r is the radius. So if I just want to like simply draw this, let's see if I can, it's going to almost look something like this. I think so, yeah, almost something like this, because we have it there, and it's going to be 7 and 3 here as a c, and this is 8 because square root of 64 is 8, and that's it. So it's going to look like this. We have this, and the problem is asking what is the maximum of this equation for y. So these are series of parallel line, and if you just solve this, you can clearly see that it's going to look like this if you solve it for y. So you are having group of parallel line that start like this, and you want to find the maximum, and as you can see, the slope is minus 3 over 4, and the maximum happens somewhere here, for example. You have this, and then you have a point here. If I call it P, for example, this P is going to be touching this circle in just one point, so it's going to be tangent to the circle. And then the idea is that what is the maximum amount that 3x plus 4y can have? There is a lot of ways you can solve this problem, a lot of ways. Let me, don't want to mix everything. This down there is for the first problem. We are just continuing with the second problem. So if you want to solve this problem, I really recommend you to think about it first, but this is what I recommend. Use Cartesian and polar coordinates because it's very handy. You will see a lot of similar problems, and if you know this, you can solve the most of them because you're now dealing with a circle. So how can we solve that? What we got is this. We got that x minus 7 to the power of 2 plus y minus 3 to the power of 2 equals 64, correct? Yes, that is correct. And then we want to find the maximum for 3x plus 4y. 3x plus 4y. 4y. So how would you solve this? Using Cartesian and polar coordinates. When you have a circle like this that is in the center, you know what is the equation for this. And when it is being shifted to some point other than what it is, you also have to consider this h and k as well. So if in normal situation your x equals r cosine theta, when you shift this, your x equals h plus r cosine theta. Okay, so that's what you're going to have. This is going to be your x, and exactly this is going to be for your y as well. If you want, I can prove this in another video. I'm not going to prove it here. It's a very simple proof. It's nothing difficult. So this is your x and y's. And now all you have to do is to just use these two, put them in this equation right here, and then use Cauchy-Schwarz to prove it and to show that what maximum would be. How is it going to look? It's going to look like this. So you have 3. What is our x here? It's going to be h plus r cosine 3. What is our h? Our h from the equation that we have. Remember, this h and k are just the shifts from the center. So h for the x is going to be 7 plus 8 cosine 3 plus 4 multiplied by our k is going to be 3. 3 plus 8 sine theta. So it's going to be 3 multiplied by 7 plus 8 cosine theta plus 4 multiplied by 3 plus 8 sine theta. And remember, this whole thing is coming from here because this is what problems is asking us. It's asking for the max of this equation there. And all we did, we just transformed from Cartesian to polar because it's on a circle, so might make everything simpler. And now all you have to do is to solve this. Let's see how we can solve it. We're going to get 21 plus 24 cosine theta plus 12 plus 32 sine theta. This one equals to 33 plus 24 cosine theta plus 32 sine theta. Okay, so this is now what we have. We have a 33. we need to find this maximum for that. So if you know Cauchy-Schwarz, it's very simple. You can show that cosine theta plus b sine theta, it's always less than or equals to a2 plus b2. So it just the maximum it can be, it's going to be that you take power of the coefficients and then take the square root of them. So that would be the maximum, because this is going to always be less than or equal. So the equal is going to be maximum. So let's just solve it for the maximum now. What are a and b? A and b are 24 and 32. So it's going to be 24 to the power of 2 plus 32 to the power of 2, which this equals 40. So the solution is simply 33 plus 40, which is 73, and that's the solution. This is a very interesting problem and very good problem, because you need to know the equation of a circle. You need to know how to actually solve it from there. There is another way you can solve it that might be more maybe a bit simpler to understand, and that would be just using geometry and the shift that you have. The way you can use that is also good, but that might be actually more complex to understand, because now you have 3x plus 4y again. Okay, you want to solve this, and the normal for this would be 3 and 4, right? The normal vector for this. And if you get the magnitude of this, the magnitude would be 9 plus 16, which is equals 5, right? So now you are shifting this vector that you have from here with that normal, and you want to grow it to the maximum. So the maximum would be just the magnitude, which is 5, multiplied by 8 would be the radius. So that would be 40. And again, we got the 40 exactly like we have it here. And for the 33, all you have to do is to just say that we have 3x plus 4y. So it's going to be 3. For this one is going to be 7. And for y, it's going to be 3. So this equals 33. And again, as you can see, we have 33 plus 40, which is 73. And that is going to the maximum. This, again, this is coming from the fact that you're just substituting in here. Our x was the equation of the circle. Remember, we are dealing with this equals 64. So this is going to be our x, and this is going to be our y. All we did, we just substitute those. So it's exactly the same method practically, but why using the polar is better? Because in my opinion, this is more practical. You do more algebra, so it actually makes you better at it, and it is much more practical in other problems that you see. Not every problem is simply like this. You can do it, but not necessarily. It could be more complex and you're gonna get stuck. But if you know this method for the polar coordinates, it's gonna be much easier. I hope you like this as well. Now let's take a look at the other section of this video, which is going to be using Vieta's formula. That's also interesting. So now let's take a look at the last part of this video, which is about Vieta's formulas. It's very handy. You need to know Vieta's formulas for the cubic, for the quadratic, and if you know the method how to calculate it, you can have it for any degree. So it's very good to know, makes everything very simple. And you can see now in the problems how it just makes everything be solved in like 1 minute instead of just like grinding to solve some equation. Again, try to solve the problems yourself. Definitely go and read about Vieta's formulas. There is a lot of like resources for that. Then come back and see if you can solve the problems. The first problem is from the BMT General. Some of the questions in there are very interesting. Definitely take a look at it. But before we start, I'm just gonna actually write them for the cubic, write Vieta's formulas. So if you have something like this, ix3 plus bx2 plus cx plus d equals 0. So the idea is that r1 plus r2 plus r3, which are the roots of this cubic equation, when you add the roots together, it's going to be minus b over a. So it's, as you can see, Vieta's formula is just connecting the roots to coefficients. So it makes everything very simple because you do not necessarily need to know the roots anymore. The other one is that, like, what if we multiply the roots together? In this case, because it's cubic, there are 3 roots. it's going to be minus d over a. And in the case of the product of the additions of the roots, so it's something like r1 r2 plus r2 r3 plus r1 r3, it's going to be c over a. Okay, so this is the Vieta's formulas for a cubic equation. Now let's see if we can solve the first problem. The first problem says, let me change the color. Let a, b, and c be the solutions of this equation. Compute 1 over a plus 1 over b plus 1 over c. So a, b, and c are the r1, r2, and r3 are the roots, and we just want to solve them. So let's just start by this. If I add a1, 1 over a plus 1 over b plus 1 over c, so 1 over a plus 1 over b plus 1 over c equals abc bc plus AC plus AB. Okay, so this is what I have. So if you just take a look at it, this is exactly what we have here. So ABC is this one, and this one is the addition and product and addition of the roots, that one. So let's just write this and see what we get. C over A. What is our C in the equation there? So we have x to the power of 3 minus 3, and I'm going to say 2021, k equals 2021. So let's always try to make everything simpler. So this is going to be k2x minus 2k3 equals 0. Okay, so if you take a look at this, you can see that a equals 1, b equals 0, c equals minus 3k2, and d equals minus 2k3. Okay, this is this coefficients for this cubic equation. Now I'm just gonna add them in here and see what we get. C over a, so it's gonna be minus 3k2 over 1 minus 3k2, and for the denominator, which is the multiplication of the roots r1, r2, r3, minus d over a. Our d is minus 2k3 over a, which is 1, and there is another minus, so it's going to be 2k3. This is going to be minus 3 over 2 multiplied by, we said k equals 2021. This is equals to minus 3, 4042. And that's the solution for the first problem. You can see how easy it is to solve this using Vieta's methods, because if you don't know Vieta's method and you can just try it, it's going to be a different type of challenge. So it just makes everything very simple. And the way to know when to use it is that when you have a problem that you feel getting the roots are actually not that easy, then always try to use Vieta's, because if you have the coefficients, there might be a way to solve it. I'm gonna delete this. This was the first problem. And now let's take a look at the second problem. This one is more interesting, a bit more challenging, because I want to also use Newton's sums here. And the thing is about Newton's sum is that this is my personal experience. If you are using Vieta's formulas, there is always a way that you also use Newton's sums. So it's a good thing to know. You always, not always, but most of the time you will have them together. And it is very good to know both of them, especially Vieta's formulas. Just remember them, and it's going to make your life much easier. So the problem, it says, let R, S, and T be the three roots of this equation. So we have R1, R2, R3 again. There are the roots of this equation. Find R plus S to the power of 3 plus S plus T to the power of 3, and so on. So how can we solve this problem? Let's just write the equation. 8x3 plus 1001x plus 2008 equals 0. So from here, A equals 8, B equals 0, C equals 1001, and D equals 2008. Okay, so these are the coefficients for the cubic equation that we have. Now let's just write the Vieta's formula for this and see what we get. If you take a look at the question itself, you can clearly see r plus s plus t, or r1 plus r2 plus r3, which are the roots of the equation that equals minus b over a, is actually 0. So we can clearly see that we can use this equation itself, this solution here, to change it in to substitute it in what the question is asking and get something very interesting. How I'm going to do that is like this. I'm going to say r plus s equals minus t, okay? Because this is equals 0, right? Then r plus t equals minus s, and s plus t equals minus r. This is what I have. So now using this and what the problem is asking, problem is asking us to calculate r plus s to the power of 3 plus s plus t to the power of 3 plus t plus r to the power of 3. Now let's just substitute every single term here. R plus s can equals minus t to the power of 3. For the other one, this is going to be minus r to the power of 3 plus minus s to the power of 3. Perfect. Now I can write everything as this: r3 plus s3 plus t3. And now that's the point. This is what we want to solve. If we get this, we just simply multiply it by minus 1 and we have the solution. So how do we get this? This is where I'm going to use Newton sums. Newton sums. And this is super handy, and again, exactly like Vieta's formula, make everything much simpler. Definitely go and read about it and see if you can solve the problem. This addition and the power, what Newton sums does is just connects and relates the coefficients of the equation to the sums of the roots, okay, to the sums and powers of the roots. So this is practically P3. What it means is that sums of the roots, additions of the roots raised to the nth power. So it's just the raised to the third power here. So if you have, for example, r1 plus r2 plus r3 that you have, that would be p1 because it just raised to the power of 1, and that's how it goes. So if you just consider this and what we get, we can actually write the whole p1, p2, and p3 very simply. It's going to be a p1 plus b equals 0. Then it's going to be a p2, which a and b and c are just the coefficients that we have, b p1 plus 2c equals 0, and then we have 3a p3 plus b p2 plus c p1 plus 3c equals 0. So this is what we have, and we want to solve it till here. So the problem already gave us a lot of information, and it's actually not that difficult now, because we already know that from what we had that r1 plus r2 plus r3, or r plus s plus t, was actually 0 from the p1 term that we had. So we know that p1 is 0, and if you take a look at the equation again itself, we had a equals 8, b equals 0, c equals 1001, and d equals 2008. So considering that, we are just going to simply solve it for this now. So it's going to be 8p3 plus 0p1, 0p2 plus 1001 p1 plus 3 multiplied by 2008, because that was our c, right? So we are solving this now, and from here we have 8p3 plus, this is 0 and this is also 0, because p1 was 0, because r1 plus r2 plus r3 was 0 for the first power. So it's gonna be 8p3 plus 3 multiplied by 2008 equals 0. From here we can just say p3 equals minus, how much that would be? 6024 over 8, which equals to minus 753. Okay, so this is P3 now. But what problem wants is minus P3, because remember, this is what problems wants, R3 plus S3 plus T3. So we have to just multiply this by a minus, so it's going to be minus plus 753, and that's the solution to this problem. And as you can see, knowing Newton's sums makes everything much simpler. If you want, I can make a video on this, just leave it in the comments. Newton's sums are very helpful in this type of problems. As another pointer for this is like a quiz you can do on yourself. For the first problem as well, try it with Newton's sums. So what I'm asking here is that for the first problem as well, try to see if you can solve it with Newton's sums for something else, or for this one as well. It's going to be interesting. There's a lot of these type of problems I'm going to solve much more. I hope you like this video. Don't forget to like and subscribe. Thank you for watching.